Reese and Michael, this is R4, or the start of R4 anyway. We are doing rational expressions and some other operations and such. They start us off with example 1, and they word this kind of weird to begin with. I had to look up what they were wanting, but determine the restrictions on the variable. Okay, so like basically what restricts the domain here, or like the input variable. Like what are we allowed to plug in for A, and what are we not allowed to plug in for A? You people who are coming from calc, your brain is thinking right along this path. Okay, like what can we plug in for A, or for X in part A, and what can we not plug in for part A?
We cannot plug in -2.
We cannot plug in -2. Okay, things that we don't ever want to have happen. Okay, these I maybe have had you written these down before, but write them down right now. DOMAIN. I call them domain errors, and there are 2 main domain errors. There's one. There's like 2.5 domain errors, but 2 main ones. And the first one is we never want to divide by 0, and the second one is we never want to have a negative inside of a square root, because we can't do that. Those are 2 things that we absolutely cannot have happen. Okay, so at all costs, I want to make sure that none of those 2 things happen. So when I'm looking at part A, on A, am I worried about domain error number 2, a negative inside of a square root? I don't have a square root, so I don't have to worry about it, okay? I just have to worry about division by 0. So what would make it so that this bottom would be 0? If X was -2. So I don't want X to be equal to -2. Does that make sense? Okay? Now, if you can't figure that out by just like doing the mental math, maybe it's something like icky, you would just say X plus 2 cannot be 0. That whole thing cannot be 0, right? I don't want that whole bottom to be 0. And then all you would have to do is subtract the 2 over to the other side, right? So X cannot be equal to -2. Does that make sense? Okay. So you can do the math that way. You don't have to just like think about it in your head. You can actually set it not equal to 0.
7.
So here's this. All right, B. Okay, I don't want that bottom to be 0. Okay, I don't have to worry about a negative inside a square root. I don't want the bottom to be 0. So here's the deal. The bottom, though, if I say that can't be 0, right? That bottom is a difference of squares, okay? So you can do this 2 different ways. You can say that can't be 0 and add the 49 over, right? Plus 49 plus 49, x squared can't be 49. And then you take the square root, like, which is what most of you guys did. And the square root of 49 is plus and minus 7, okay? Now, some of you guys forget to put the minus on the 7, because when we insert the square root in there, it has to be plus and minus, okay? So, rather than doing it that way, just wait, hold on. We'll plug it back in and you'll see, okay? Rather than doing it that way, Eli said that he wants to go ahead and separate it into x minus 7, x plus 7. Can't be 0, right? And then if you do that, then you won't forget to put the plus and the minus. Does that make sense? So if you factor it down as a difference of squares, then you won't forget the plus and the minus. Okay, this x can't be 7 and x can't be -7. So I don't care how you do it. You can do it either way, but this way you won't forget the plus and minus, whereas here you might, right? Okay, now what did you say, Jose?
I thought you said we can't plug in a negative for a square root.
Oh, there is no square root here. It's just the denominator, right?
That's the...
Does it have to be in the actual problem, the original problem?
Yes.
Okay.
Yeah. So like if I were to try to plug in positive 7 squared minus 49, this is going to be 0. And so I don't want 0 to be in the bottom. I can have 0 in the top, right? So technically I could plug 0 into this equation right here and get 0 on the top, and then I would get, what, -49 on the bottom? So it'd be 0 over -49, which is totally illegal. Do you know what 0 divided by -49 is? No. 0. 0 on the top is just 0. 0 on the bottom is undefined. Okay, so we can't do that. Maybe we should write that down. Let's write that down over here. Over by domain errors. 0, let's say 0 over a number equals 0, but a number divided by 0 is undefined.
Is it undefined?
Or 0 with a line through it. Okay,
Wait, what
undefined.
0 over 0?
If it's 0, we already talked about this, right?
Friends don't let friends
0,
divide by 0.
yeah, friends don't let friends divide by 0. 0 divided by 0 is they call it the indeterminate form, and that's like what we did with limits and stuff. You won't see very much of that happen in Trig. But it's kind of like undefined also. It's just a different version of undefined.
You have to use undefined, you can't use D&E?
No, don't do DNA for these. Okay. So that's B. C, we have two variables in the bottom, right?
Ew.
So we have to say, like, what can X not be and what can Y not be? Anybody have any guesses?
0.
0. If X is 0, I would have 0 squared, which makes the whole thing 0, right? What about Y?
Zero.
Also 0. If 0 is here, anything times 0 is 0, right? So I can't have 0 in the bottom, right? This is a monomial, and when you're multiplying everything, usually the value is going to be that it can't be 0 because 0 is just going to knock the whole piece out. Does that make sense? Okay. So X can't be 0, Y can't be 0, that type of thing. Got it?
No.
Questions about that? Okay, so when they say determine the restrictions, they're asking for the domain. Like, what can X be and what can X not be? X can be anything else but these numbers, right? X can't be what we've designated. Okay? Got it? All right, simplifying rational expressions. We ended the year in Algebra 2 last year doing this very thing. So if you're coming from Algebra 2, maybe you remember this. I don't know. Here is this guy, okay? We want to simplify. There's only one piece here. We're not multiplying or dividing or doing anything. We're just trying to break him down as much as we can. What would you like to do?
Squares on the top, right?
Difference of squares on the top. So x squared minus 16, he is what?
X squared minus 4 plus 4.
X minus 4, x plus 4. Doesn't matter which one you go first, okay? On the bottom, what is he? He's a simple trinomial. What can we multiply to get 14, but when I, or excuse me, 12, but when I add them, give me, this is negative 1, right?
3 and 4.
What?
3 and 4.
4 and negative 3? No, negative 3 and positive 4. Yeah.
No.
No,
4.
negative 4, positive 3. Is that what he said? I don't know. We're all saying the same thing, and then I'm just confusing us. Okay, now what?
Cross out X minus 4.
The x minus 4s can cancel. So, anything else can cancel?
Nope.
Can I cancel these x's?
No, because they're grouped.
To have like 4 over 3?
No.
I always call them trapped, because if you have something plus something, they are trapped together. This is like their one unit, okay? So you can only cancel them if that whole unit cancels with another whole unit, okay? So this is x plus 4 over x plus 3. What'd you say?
This is revealed.
This is
None of the other stuff is revealed.
Chapter R. This is so far the only thing that's been an R from chapter R. Okay. So there's this guy. Now, what can x not be?
Negative 3.
Negative 3. I don't know if they asked for that. Here they just wanted you to simplify, so they don't necessarily probably have to do that, but there's that. Okay? All right, B. How the heck do we even simplify B?
Well.
Well,
Can you cancel the 4 and the 2, like divide? Or is it
Erase
trap?
it.
what?
I wish. Square it.
Put
Yeah.
one over it.
So this 4 is on the bottom for everything, right? Another way of writing that is 8 over 4 plus 2 square root of 7 over 4. We can break them apart, right? And do that. Now, what we can't do, let's say this was 4 on the top and we have 8 plus 2 square roots of 7. That is not the same thing as 4 over 8 plus 4 over 2 square roots of 7. That's not the same thing, right? But if it's a bottom number, we can split it out into 2 pieces, right? Okay? All right, so we do this, then we can do some things. What is 8 over 4 reduced to? 2 plus, now this 2 and this 4 can reduce to 1/2, okay? So I'm going to write it as the square root of 7 over 2. It's like there's a imaginary 1 out in front there, right? So 1 and 2, but I'm going to leave the 1 off, and that's how he's going to be written. Make sense? Happy with that?
And 2 plus
Yeah?
square root of 7 over 4.
What?
So there is no X. Okay.
2 plus the square root of 7 over, yeah, there's no x.
So was-
Now, you can also reduce this to be like this. Let's say we have this top piece right here. There's 2 terms here. What can I pull out?
A 2?
A 2. If I pull a 2 out, I'm left with 4 plus the square root of 7. True?
Yeah.
All over 4. Now I can cancel this 2 and this 4 to be 1 and 2, right? Which is 4 plus the square root of 7 all over 2. This is technically the same as that, right? Okay, it's just the 2 out in front, then we've reduced that. So either way, I don't know which way they want you to do it. Your book still up? Or, this is Eli's book. They wanted you to do this way. This is the way that they showed. But this means the same thing. So either way, I'm fine with.
Is it 2 plus square roots of 7 over 2, or is it?
The 2 is off by itself. So this is technically like 2 over
So
1.
you have to have the addition sign?
Yes.
Why
That's
can't
just
you,
two
why
of
can't you, like, 2 over 1. Oh, wait.
That's what we did here.
Oh,
Right?
Yeah. Oh, yeah.
Yeah, so either way, I will take either one. Those two, the book did it this way. I did it this way, because the 4 over 2 that can reduce down even more, so, yeah, it's fine.
Why would the book do it like that?
I don't know, or maybe they did. Nope, they only did it one way, they did it that way, that's fine, whatever,
Alright, it's not fun.
whatever they
I
want,
don't like it.
okay, sure. We're just gonna do it our way then, which is fine, we'll do the blue way, okay? Alright, let's talk about this guy, 4 minus x and x minus 4, let's talk about him real quick. Because when you see him, 4 minus x is not the same thing as x minus 4, because up here at the top, the x is the one that has the negative, but at the bottom, the 4 is the one that has the negative. So this is like a positive 4 and a negative 4, and those don't cancel, right? Or a negative x and a positive x, that doesn't cancel. But what we can do is, this top, I'm going to pick on the top. It doesn't matter if we do it to the top or the bottom. The top, if I take a negative 1 out in front, right, like I pull a negative 1 out, this 4 is going to become negative 4, and the x is going to become positive x, right? You see that if I pull a negative 1 out? Or in other words, this would be negative 1 and then x minus 4 if I switch these two around, right? But then
Top and bottom cancel.
x minus 4 and x minus 4 cancels, and the answer is just 1, negative 1. I'm sorry, negative 1 is all that I have left over. You see that?
Yeah.
Clear as mud, right?
Yeah.
So you can take a negative out if the signs are flip-flopped from what it is right now, okay? You can take a negative 1 out and it might cancel that way, okay? So be looking for those. If you see two things that are like kind of similar to each other, see if you can factor a negative out and have them be the same. Got it? All right. Let's go to this guy right here. Dividing rational, go to example 3. Next page.
Ew.
Top of the next page.
I don't think I can do that.
Divide.
I don't think my brain has
Dividing
process
rational
to do that.
expressions. Dividing rational expressions. Okay. Dividing. Here we go.
Is this like the canceling thing again?
Keep
What?
flip.
Yeah, we gotta keep flip. So if you're coming from algebra, this is maybe straight in your head. This is a division. We have to flip it. Okay. Yeah, let's do that. I'm not gonna do too many steps at once. Okay, so there's this guy, and the bottom guy, I'm gonna write him as negative x squared plus 4. Can I do that?
No.
Yeah, you can.
Sure, let's do it. Okay. Then I'm gonna multiply by the reciprocal of this. So x squared minus x minus 6, he's gonna go on the top, and then this guy's gonna go on the bottom. There's lots of stuff happening here. Holy crap.
Wait.
She just flipped the bottom.
I just flipped these two right here.
Yeah, flip.
Yep.
We did that in Kramer's class.
Yeah,
You
keep
guys
flip.
did the bottom
You
one,
did it in my class in algebra 1 or algebra 2.
like on the x squared plus 4.
What's her
Isn't
name?
that different to squares?
It's something with the perfect something.
Yeah, he is, but I'm gonna write him like this, and then we're gonna factor a negative 1 out first before we do difference of squares. Okay. All right, do you see what we flipped? We flipped just this piece. This is the only thing I flipped, because in keep, flip, you gotta keep the first part, you gotta flip the second part, you gotta flip the last part, right? We flipped the division and multiplication, we flipped the fraction, okay? All right, keep, flip. All right, let's go piece by piece. This guy right here, he is a something.
He's a
There's
cube.
cubes.
The difference of something.
He's a difference of cubes, okay? Difference
Yeah,
of cubes says a minus b,
Ew.
a squared plus ab plus b squared. That's the rule for that, okay? That's
Why?
the
How did
rule
they even
for,
get that?
Yeah,
That
doesn't make
thing.
any sense.
What?
That didn't make any sense.
I don't know. It's gonna here in a minute. You just wait. It's gonna cancel real nice, real
I know
nice.
it is.
Okay? All right, so when I take the square root, what is the a part? X and the b part is,
2.
this is a cubic root,
X minus
is 2, okay? So we have x minus 2, okay? That's the a minus b. And then we have a squared, which is x squared, and plus b squared on the end, which is plus 4. Is that true?
Yes.
Plus a times b, which would be 2 times x. There's that top. You see that? That was a perfect difference of cubes. Okay? All right, real quick. This bottom, negative x squared plus 4. I'm going to pull a negative out. And if I do that, I get x squared minus 4. Do you see that? If I pull a negative out.
And then you can do the difference of squares.
You see where I did that? Nod your head yes, okay. So I pulled the negative out. Now I'm going to take that x squared minus 4 and I'm going to make him x plus 2 and x minus 2. Okay, but we can't forget the negative 1 that we pulled out. So x plus 2, x minus 2, that's my difference of squares. Okay, got it? All right, this is going to be real fancy, real fancy. This top part is a simple trinomial. Multiply to get 6, add to get negative 1.
That's what you so dumb.
Negative 3 inches.
X minus 3 and x plus 2. Yeah? Okay? Now this bottom,
2 and 6.
Take in 3 out.
take a 3 out. Okay, let's just take a 3 out and let's see what we've got. If I take a 3 out, I have x squared plus 2x plus, oh baby, look at that. You see it?
Yeah.
Those 2 can cross off.
That's nice. That trinomial can cancel with this trinomial.
Then those two x's can cancel.
This x plus 2 and this x plus 2.
And then the other, like,
X minus 2.
x minus 2.
And x minus 2 and x minus 2.
So we have
And
We're
x.
canceling all over the place. So on the top,
X
can
minus
this 3 cancel with this 3?
No,
No, because the 1 on the top is trapped, right? So on the top, what's left over?
x minus 3.
X minus 3. On the bottom is
Negative 3.
3 minus 1.
negative 1 times 3, which is
Negative 3.
negative 3. Can those negative 3's cancel?
No,
So it's just x?
no.
No, because one of them's trapped, the other one's not. The bottom one's not trapped, but the top one is trapped. Do you see that?
Oh,
So he's done. Okay?
That was nice.
Alright, when we do this, do we say x can't be 3?
No, we say it can't be positive 3,
But
right?
x can be anything.
X can be anything.
Oh, because
It's not on the bottom. It's not on the bottom, so x can be anything it wants to be.
So
right?
x equals all reals.
X is all reals, if they ask for that, right? But they're not asking for that necessarily. Okay, now what's the difference between that and this?
You see.
Like if I take this negative, can I pull it out front?
no.
No.
Yeah, you can.
No.
Yeah, you can.
Probably.
It's like let's say I have 3 divided by negative 1. That's the same thing as negative 3, right?
Yeah.
The negative could go out front, right? If it wants to.
But then wouldn't it change?
Nope.
up top?
Nope.
I like
So
the
either way, whatever.
first version better.
You like first version better? Okay, there you go. Happy with that?
Sure.
That was a multiply divide stuff. Okay? Let's do one of these adding and subtracting just to get our feet wet and then we'll stop. Okay? And then I'll set you free. Okay?
Our feet want to be.
Your feet are already soggy.
I did.
Yeah. So
Okay,
we
we'll do
suck
this
so
one. This
good.
one is kind of maybe an easier one because this is okay. Adding and subtracting is a lot harder than multiply divide. When you are adding rational expressions, do you remember why?
Yes, they.
You have to find a common denominator here, whereas multiply divide you did not. So common denominator, right? Do you remember doing this? Common denominator? Okay. This one's not so bad, but here when we're starting to do stuff like this where it's really super ugly, common denominator there as well. We'll do the easy one first and then we'll be done. Okay, and then we'll start with that tomorrow. Okay. Common denominator. We have to find a common denominator. Another name for common denominator is the least common multiple, the LCM. Least common multiple. So I want a number that they both go into.
240.
Nope, that they both go into.
20.
So
No, so
starting
they
with
can be
4
divided
and
by
10. What number does
20.
4 go into and 10 go into? 20, okay? If you're stuck, this is how I do it. You ready? Which number is bigger, 4 or 10?
10.
Start with 10. Does 4 go into 10?
No.
No. Now we're going to go the next number up from 10, which is 20. Does 4 go into 20?
Yeah.
Yes, there's where you stop. So start with the biggest number, do multiples of him, and see if the other ones go into him, okay? So we're going to start with 20. How many A's do you need to have?
Squared.
In order for everything to go in there, I have to have A squared, okay? So let me ask this question. Does A go into A squared?
Yes.
Does A squared go into A squared?
Yeah.
Then that is my least common multiple. Got it?
20 A's.
Okay, 20A squared and 20A squared, all right? Some of you guys can use shortcuts. I don't care. I'm going to put 7 here and 11 here, and then we're going to multiply by what he needs. Okay, he might not need anything. 7. To get from 4 to 20, what do I have to multiply by? 5, and he also needs A. Yes, so he will be 35A at the end.
Plus
Okay.
11.
This guy, what does he need to be multiplied by?
2.
2. Does he need an A?
No.
No. Okay, so on the top,
22.
35.
this is 35A plus 22. Can you put those two together?
Could you cancel out anything? Like in these?
Uh-uh.
Like,
Well,
no,
you don't
can't.
want to because we're trying to put them together.
I know.
You can't
So-
put them together because
Seven,
the A attracts
I know.
35,
Right, yeah.
57.
The A is not trapped in the 35. He could cancel. He could cancel. This guy could cancel with one of these, but it gets me back to the beginning,
35A
right?
plus 22.
57A.
You can't add
Okay.
those together.
35A on 22 is, we can't, this one's not, doesn't have an A on it, Carter.
That was Eli.
Oh, yeah.
Or Eli, I mean, sorry. 35A plus 22, that's it. Over
28.
20A, that's all. That's all we can do. Find a common denominator and add
Isn't it
together.
A squared?
Is it A squared?
Oh, A squared, I'm sorry. Yes, you're right. Thank you. I was just seeing if you're paying attention. And you were. Ha, good for you. You passed the
I
test.
don't know how.
Okay, that's enough,
Yep.
right?
Good.
That's,
We'll quit
that's
there.
fine.
That's, I mean, we've got lots of time to do more notes, but I don't want to snow you. So,
It's already sleeping.
it's already sleeting? Okay.
Yeah. we're
All right,
slowly-
there you go. So you should be able to do through example 4 adding rational expressions. Let's
Take a nap.
mum.
I need to do it.
Let's go add rational expressions. You should be able to get through 36. Do I give you 36? 34. You should be able to get through 34. Yep.
No, 44.
34. 44 is gonna be more of a Oh, you can do 44. You can do 44.
Aren't there like the pink, orange, and green
Tommy,
ones
I have a
too?
question.
44. You can do through 44.
Yeah, answer your question
If
to
you
me.
start. 48 I would wait on. 44 you can do. Okay? Good? That's Eli's. I'm gonna pass it
Tommy, I
back
have
to
a
him.
question.
Alright, goodbye people watching this video.